welcome to 2.3 page 4, and we can get started right away here on 60 and 62. We're going to have some explanation, but we should be good to go here. Verify the given factors of the function. They're telling me x plus 2 and x minus 4 is a factor. Well, if x plus 2 is a factor, it will divide this. Negative 2 will divide it, or x plus 2 will divide it. 4 will synthetically divide this, and I'm going to use synthetics, so let's get started. I'm going to take negative 2 into 8x to the fourths, negative 14x cubes, negative 71x squareds, negative 10x's, no holes, and a 24. With the synthetic division, I'm actually, based on the directions, I'm actually expecting to get 0 here. Let's see. I get, bring down 8 times negative 2, negative 16, negative 30, positive 60, negative 11, positive 22, positive 12, negative 24. Sure enough, we've got 0. So I verified that this is a factor. And now if x minus 4 is another factor, I'm going to divide this result down by negative 4. So, or excuse me, synthetically by positive 4, the MyVox. Positive 4. So 8, 32, 2, 8, negative 3, negative 12, and sure enough, there we are at 0. So what I've got right now is I've got factors of x plus 2, x minus 4, and when I divide those, I'm left with 8x squared plus 2x minus 3, which may factor. If there are factors of negative 24 that add up to be positive 2. And that would be 6 and negative 4. So that factor's final solution, I'm going to have to kind of jam this in here. X plus 2 times x minus 4 times, those are going to factor. I'm going to have the outside product be negative 4x. To get a negative 4, I'm going to use the full 4 from here. So that's 4x and just minus 1 from there. First times first equals first. 4x times 2x. Last times last equals last. Negative 3. So negative 1 times positive 3. So there's my missing 6. And we've got it. That is our jam-packed solution right there. Okay, 58. 2x minus 1. Now, if 2x minus 1 is a factor, then 2x minus 1 makes this equal to 0, so x equals 1/2. 1/2 is a 0. So I'm going to synthetically divide 1/2 into 2x cubes, negative 1x squared, negative 10x's, and 5, no holes. 2 times 1/2 is 1. That gives me 0. That's nice. 0. Negative 10. Half of that, negative 5, and sure enough, we get 0. So currently, we have x minus 1/2 and 2x squared, 0x's, minus 10. Now note, we can factor a 2 out of here. I'm going to factor a 2, setting this thing equal to 0. I'm going to factor a 2 out of here. Actually, we're just factoring. Don't need that. Factor a 2 out of here, but I'm going to distribute it into there. Factor it out, distribute it in. Back to 2x minus 1, what we started with. and then x squared minus 5. So it says find the remaining factors, use your results to write the complete factorization, list all the zeros. So let's go back up here. Our zeros are x equals -2, 4, -3/4, subtract 3, divide 4, add 1, divide 2. I'd forgotten about that. Now, this is factored. We can actually factor this again into x plus square root of 5, x minus square root of 5, but this is factored over rationals, so that's typically what we do. And if we set that equal to 0, I get either x equals add 1, divide 2, or x squared equals 5, x equals plus or minus square root of 5. So there's our factored form, and there are our zeros. Okay, now, in the age of graphing calculators, this rational zero test is not as important as it used to be. It still has its place, and we're going to go back to the front page and talk about that one a little bit. I'm going to give an example of what they're doing here. I don't think this is very clear without an example. So let's say we had 4x to the 5th and then a whole bunch of other things, and eventually we ended up with a plus 6, and we got a 4th term to the 3rd to the 2nd maybe. We got some missing terms in there. Now, if this was factorable, let's say it was factorable into 5 linear factors. Let's say we could get 5 nice factors out of this. What would we know about each one of those factors? Well, this times this times this times this times this would have to be 4x to the 5th. We'd have something x, something x, something x, something x, something x, and if I multiplied all the somethings, they'd have to multiply to be 4. That means this has to be a factor of 4, we use that notation, times x. And then plus or minus, if I took this times this times this times this times this, they would have to multiply to be 6. So this has to be a factor of 6. Any linear factor is a factor of 4 plus or minus a factor of 6. Now if I set that equal to 0 and solve for x, I would get x equals, I would either add or subtract the factor of 6, so that's minus or plus or minus, and then I would divide by a factor of 4. It's the factors of this constant term divided by the factors of that lead coefficient. That's what they're talking about here. It says it has integer coefficients, then every 0 of f has the form rational 0 is p over q. Watch this. Where p is the factor of a0, p is a factor of this, or in our case a factor of 6, divided by q, which is a factor of the lead coefficient, in our case a factor of 4. So it's the factors of 6 on the factors of 4, or the factors of the constant on the lead factors of the lead coefficient. Okay, I don't expect that necessarily to fully make sense, but I think it will after we go through this. Use the rational zero test to list all possible rational zeros, then find the rational zeros. And this is where we're headed in the next section. So my rational factors would have to be a factor of 16 over a factor of 1. Now my factors of 16 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. My factors of 1, mercifully, are just plus or minus 1. So my possible rational zeros are plus or minus 1 on 1, and you know it's going to end up just being these, but typically that won't be 1. Plus or minus 2 on 1, plus or minus 4 on 1, plus or minus 8 on 1, plus or minus 16 on 1. Now, take you back many, many, many years pre-graphing calculator. What we would need to start doing is start going through and test, synthetically divide. Does 1 turn this into 0? Does negative 1 turn it into 0? Does 2? Does negative 2? Does 4? We'd have to synthetically divide any of those until we start finding some. And then we could start breaking this down and factoring. Then we could start reducing this thing like we just did up above in the previous problems. I'm not going to require you to do that. I am going to have you list the possible rational zeros just so we've seen it. I'm going to go into calculator now. Let's see if I can get that screen a little bit cleaner so it doesn't glare. That looks a little better. And I'm going to go in and clear this, and I'm going to enter that function. Let's go x cubed minus 4x squared minus 4x plus 16. I think we actually could have factored this without doing that. Let's go zoom 6, and let's see if we've got some zeros that look like they might coincide to these. Looks like 2, 2, and 4. Second calc value, let's see, negative 2 is a 0, 2 is a 0, 4 is a 0. So list all the possible rational zeros, then find the rational zeros, and I'm just going to say this was done with calculator, therefore we're going to graph it. We got a 0, we got a 0, and we got a 0, and it looks something like that. The zeros are x equals negative 2, positive 2, and 4. And you note that those were in our list up here. You don't have to go through the trial and error. I will never have you go through the trial and error method. Okay. But normally we would be using synthetic division to do that. Alrighty, so here I need the factors of, the factors of 2, or negative 2, doesn't matter, over the factors of 4. This one wouldn't be too bad because there aren't that many. The factors of 2 plus or minus 1 plus or minus 2. The factors of 4 plus or minus 1 plus or minus 2 and plus or minus 4. So our possible rational zeros. Now there could be other zeros. These are just the ones that could be written as a fraction of integers. So this is not foolproof whatsoever. Our possible rational zeros 1 on 1. So plus or minus 1. 1 on 2. Plus or minus 1/2. 1 on 4. Plus or minus 1/4. 2 on 1. Plus or minus 2. 2 on 2, but that's 1. 2 on 4, but that's 1/2. So we would need to take those 8 values and synthetically divide this through here to find out which ones work. As many as 5 of them could work. So let's do it this way. Clear. We've got 4x to the 5th minus 8x to the 4th minus 5x to the 3rd, double checking all the way, plus 10x squared plus x minus 2, one more double check, 4x to the 5th minus 8x to the 4th minus 5x cubed plus 10x squared plus x minus 2. Let's graph it and see if we have any decent zeros here. Okay, based on this, it looks like possibly negative 1, possibly negative 1/2, possibly 1/2, possibly 1, possibly 2. Let's check. Second calc value is negative 1 a 0? Yep. Is negative 1/2 a 0? Yep. Is 1 a 0? Uh-oh. Why? Let's graph again. Second, not sure what I did there. 0 is, oh, that, yeah, I didn't want to do that. Second calc value. Okay. Where am I at here? 0.5. Yep. 1. Yep. 2. Yes. Now understand, they did not have, there could have been 5 zeros and them not be rational. This could have just been square root of 5 or something like that. But we have possible rational zeros, and our zeros are actually x equals negative 1, negative 1/2, 1/2, 1, and 2. And let's go ahead and sketch the graph so we know we didn't just get the answers from the answer key. So negative 1, 1, 2. We got a 0 here, a 0 there, a 0 here, a 0 there, and a 0 there. And it goes up, comes down, comes up, comes down, and goes back up, something along that order. Okay, 16 minutes on that. There's a lot of explanation, and some of those do take a little bit of time. Let me know what I can help with. Good luck.